Hi, welcome to my video on division of monomial square root radicals, part 2. Simplify each radical before rationalizing. In the previous video, all the radicals underneath the root were simplified. Now we should simplify the radical underneath the root before we rationalize the denominator. Like the root of 18 is 9 times 2, so it's 3 root 2. The root of 27 is 9 times 3, so that gives me 3 root 3. So I have them simplified. Simplifying these makes it easier, because if I didn't, just watch, if I did the root of 18 divided by the root of 27, I would have to multiply by the root of 27 over the root of 27. The bottom is okay. Root 27 times root 20 is 27. But imagine trying to simplify root 18 times root 27. So you have to multiply 18 by 27 and get a big number and break it down. So rationalizing root 18 and root 27 and then simplifying it makes the problem easier. So because I simplified it, 3 cancels, so I get a root 2 over root 3. That means I can multiply by the conjugate of root 3. Because the conjugate of root 3 is root 3. Root 3 times root 3 is 3. And root 2 times root 3 is root 6. So simplifying makes it easier. And in this one, if you simplify the root of 25, you get a 5. If you simplify 28, 28 is 4 times 7. So that becomes a 2 root 7. Now that the two of them are simplified, it's easy to do the conjugate of your denominator, which is, root 7. The conjugate of 2 root 7 is root 7. So you multiply top and bottom by root 7. So 5 times root 7 is 5 root 7. And you have 2 times 2 root 7 times root 7. So you have a 2 root 7 times root 7. So that's 2 times 7. Root 7 times root 7 is 7. So that gives you 14. And 5 and 14 can't cancel. You cannot cancel the irrational number with a rational number. You can only cancel within these two. C, we have root 20. Root 20 is 4 times 5. So that becomes 2 root 5. And the square root of 9 simplifies to a 3. That means your denominator is rationalized. So this is the answer. Or you could have 2 over 3 root 5. Your choice. Either way. You could have here, that's a 1, so this could be 1/3 root 6. And this one could have been 5 over 14 root 7. So either or. You can leave it as root 6 over 3. You could leave it as 5 root 7 over 14. Or you can leave it as this answer. Your choice. I say an or here. Don't have to do both. And D, we have to simplify root 50. So root 50 is 25 times 2. So that's 3 times 5 root 2. And root 48 is 16 times 3. So that's a 4 root 3. And notice we get a 3 5s are 15 root 2 over 4 root 3. So notice you can't reduce 15 and 4. So you have to multiply by the conjugate, which is root 3. 15 times 1 is 15. Root 2 times root 3 is root 6. And 4 root 3 times 3. So 4 times 1 is 4. Root 3 times root 3 is 3. So that gives us a 12. And now 15 and 12 have a factor of 3. 3 into 12 goes 4. 3 into 15 goes 5. So I get a 5 root 6 over 4. Remember, you cannot cancel this root 6 and this 12. You can only cancel within this fraction. E, let's see what we have. Root of 12. 12 is 4 times 3, so that's a 2 root 3. we have an 8 and the root of 45. 45 is 9 times 5. So that becomes 3 root 5. So 45, root of 45 simplifies to 3 root 5. Root of 12 is 2 root 3. Now, if you want, you could reduce this fraction here to make it simpler, or you can keep going and rationalize. So it's your choice. It's your choice. So you can go, I'll go two ways. I can go 2 root 3, and 8 times 3 is 24 root 5. So let's go this way and work over here, and then I'll do it the other way. So notice now that the 2 and the 24 can simplify. So if I reduce, this is 8 times 3, and this is 2 on top. So the 2 can cancel once, 2 and the 4. So that could become root 3 over 12 root 5 if you want. Or you could do the multiplication like I did here and then reduce this. But reducing it makes it easier as you go. So if I reduce here, 2 and the 2 goes once, 2 and the 24 goes 12. So I get a root 3 over 12 root 5. Either way, you can reduce it as you go. It makes it easier. If you wait till the end, your numbers are going to be bigger. So if you multiply this by the conjugate of root 5 is root 5. Multiply the top by root 5. It gives you the root of 15. And this is 12. Notice 12 times 1 is 12. Root 5 times root 5 is 5. So that gives me a 60. And you cannot cancel the irrational number and the rational number. Okay. So just explain these things. And simplify each. That means rationalize the denominator. But before we do it, we should simplify each radical. Practice. Practice. Do one at a time. Press play when you get it done to see if your answer is right. So 20 is 4 times 5. So that's a 2 root 5. 12 is 4 times 3. So that's a 2 root 3. That reduces, so let's cancel the 2's. So I get root 5 over root 3. So I multiply by the conjugate of root 3. So that gives me root 15. And root 3 times root 3 is 3. So I could have, if I want, as a 1. So I could have 1/3 root 15. Either or. I'm just doing both options. Number 2, root of 27 is 9 times 3. So that becomes a 3 root 3. This is already simplified, so that's a 3 root 2. Now, notice you can't cancel here, but you can right here. 3 is cancel, 1 and 1. So that becomes root 3, and I'll write it down right here, root 3 over root 2. Now we multiply by the conjugate, which is root 2 and root 2, because we got to rationalize the denominator. It's the denominator we want to make a rational number. And so root 3 times root 2 is root 6. Divided root 2 times root 2 is 2. Or we could have 1/2 root 6, because that's a 1, either or. Root 6 over 2, or 1/2 root 6. Number 3, we have to simplify the radicals first. Makes it easier. So we have a 15, and 24 is 4 times 6, so that's a 2 root 6. And root 5 is already simplified, so we get a 2 root 5. Now we're multiplying this. We could, if we want, multiply these, or we can cancel. Because this is all multiplication, we can cancel. 2's cancel 1, 1. So that gives us 15 root 6 over root 5. We could have multiplied and got 30 and then divided by 2. So if you cancel the 2's because you got all multiplication, you're okay. Or if you didn't, you got 15 times 2 is 30 root 6 over 2 root 5. Now, if you divide 2 into 30, you get 15, so you still get to this step. The conjugate is root 5, top and bottom to balance it. Multiply 15 root 6 times root 5 is root 30. All over, root 5 times root 5 is 5. And we can't cancel the 5 into the 30 because that's irrational, that's rational. But 5 into 5 goes once, 5 into 15 goes 3. So it's 3 root 30. Number 4, we've got to simplify the radicals first. So let's see what we have. We have a 7. 200 is 100 times 2. So that's 10 root 2. Done. The bottom cannot simplify because it's root 7. Now we can cancel here because we got multiplication. It makes it easier. So 5 into 10 goes 2. 5 into 15 goes 3. So we have a 14. 7 times 2 is 14, root 2 on the numerator. And we got a 3 root 7 in the denominator. Conjugate of 3 root 7 is a root 7. Root 7 on the bottom, root 7 on the top. That gives us 14 times 1 is 14. Root 2 times root 7 is root 14. And the bottom becomes 3 times 7. So 3 times 1 is 3. Root 7 times root 7 is 7. So that gives me a 21 on the bottom. And notice, I repeat, you can't cancel these two because that's irrational, that's rational. 7 and 14 goes 2. 7 and 21 goes 3. So you get 2 root 14 over 3. Let's continue. How are you doing? Simplifying. Just takes time. And you always cancel. Remember, you're dealing with fractions, so you can cancel anywhere, top to bottom. Except you cannot cancel a rational number into an irrational number. Let's continue. Let's see. The square root of 48 is 16 times 3. So that's a 4 root 3. 28 is 4 times 7. So that's a 2 root 7. Simplified. And we can cancel here. So 2 was 2 times 2, 4. And that's a 4. So they can all cancel out. 1, 1. So that gives me root 3 over root 7. And we multiply top and bottom by root 7. So the numerator becomes root 3 times root 7 is root 21. Root 7 times root 7 is 7. And again, we could go or. There's a 1 over 7 root 21, because that's a 1 understood right there. And the last one, notice we cannot cancel the 5 and the 18, so we have to simplify these roots first. So what does that give us? It gives us 5, and that's a root of 36 is 6. 18 and 8. The 8 is 4 times 2. So the square root of 4 is 2 root 2. And now we can cancel here, we can multiply, but I'll do it both ways. Do it both ways just to show you. If you cancel here, which is what I believe in, much of this, I can cancel this and I could get 6 into 6 goes once, 6 into 18 goes 3. So that gives me 5 times 1 is 5, all over. 3 times 2 is 6 root 2. So because I canceled the 6 out, then my problem is easier to deal with. Then I can go root 2, root 2. 5 times root 2, 5 root 2. That's a 6 times 1 is 6. Root 2 times root, that's 6 times 1 is 6. Root 2 times root 2 is 2. That gives me a 12. And there's my final answer. But if you didn't cancel, what would happen if you didn't cancel this 6? You go 5 times 6 is 30. And you go 18 times 2 is 36. And you get root 2. So if you didn't cancel the 6, the top will become 30. And the bottom will become 36 root 2. Now you got bigger numbers. So if you don't cancel as you go, like I did here, but if you wait and cancel here, then you get 6 into that goes 5, 6 into that goes 6, so that gives you 5 over 6 root 2. And then you're right to here. But if you didn't cancel there, you would have, let's pretend, let's go out of this one right here. Just watch. If you didn't cancel, like here I canceled a 6 and made it easier. Here, if I multiply these two, and I got this, and I canceled a 6, but if I didn't cancel at all here, and I didn't cancel here, watch what happens. I get 30, and I get 36 root 2. So I never canceled here, never canceled a 6. I got 30 and 36. I never canceled a 6 here. I would have to go root 2, root 2. So that gives me 30 root 2 over 36 times 2 is 72. So eventually I would have to cancel down here. So canceling at the beginning makes it easier. Canceling, because you're dealing with multiplication on top and multiplication on the bottom. So I can cancel as I go. Makes it easier. But if I didn't cancel till the end, then what would happen? 6 into 30 goes 5. 6 into 72 goes 12. So canceling at the beginning to go to here makes it easier. But if you cancel and wait till the end, then you got bigger numbers, as you can see. That brings us to the end of this video. If you like my video, click the like button, the subscribe button, and the notification bell, because there are more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, the videos, and the content. Hope you enjoyed my video. Thank you very much. Bye-bye.